Hey guys, today we have a 12 volt 100 amp hour lithium iron phosphate battery from DFun. This company is also known as DFun Tech, and prior to their recent change of name, it was previously known as Vico Battery. And then from what it sounds like, DFun Tech purchased out the company Vico Tech. So at this point, you're probably thinking the same thing I am, and that is that this battery looks strikingly similar to an SOK. It's pretty much identical from the external view, other than this one has rounded corners. Other than that, the lettering on the front looks pretty much the same. We have the same terminals, the same terminal caps, the same handle, so it sure will be interesting to see the differences inside. So a quick glance at the outside of the battery. See, it's model number DFPA12100. This battery is good for a 100 amp hour continuous discharge or a peak surge of up to 200 amps. The recommended charge current is 50 amps. The maximum charge current is 75 amps. Taking a look at the terminals, we have these rubber caps for protection. We have an M8 bolt, and this connector is bolted down to the case. One difference between this and the SOK is that I noticed there is no gasket under this terminal like there is on the SOK. I've also noticed that this terminal has two raised plastic pieces on both sides. I don't know that I really like that myself, because that means your lug can only exit from these two sides of the terminal. You cannot have the wires coming in from the left or the right. Because obviously these plastic pieces are going to get in the way. And then we have pretty much the same handle on top for carrying the battery around. And we're charging at approximately 41 amps. So I've got my usual capacity testing setup here, which is a Baytrium shunt, a 2000 watt inverter with a series of incandescent light bulbs connected, and a tablet display here showing the battery's voltage, amperage, wattage, discharged amp hours, and discharged watt hours. Like usual, the goal is to get a 0.2 C rate on this battery, which is approximately a 20 amp load. We'll run this test until the BMS in the battery shuts down, and then we'll see what our measured capacity is. Alright, so 2 incandescent light bulbs is right around 22 amps. We'll be back when this finishes. Alright, so our test just concluded. We came in at 106.9 amp hours. That is quite impressive and is quite a bit more than I would have expected. Alright, and this battery is very easy to open, which we like. There are simply a series of Phillips screws around the top of the battery case. And then hopefully all we have to do is pull the lid off here. There's a temperature sensor. Let's get that temperature sensor off. Uh-oh, those wires aren't even tight. So what we have here is, it looks like a standard JBD BMS, and then they have the temperature sensor coming down to the bus bar here. And I cannot pull the lid off without removing this screw, but before I do that, I wanted to show you the screw is also holding down the balance lead, and you can see it's not even tight there. So that's not good. Alright, so with the tension relieved on this temperature sensor, I was able to flip the lid over fairly easily. And what I really want to focus on are these balance leads, because like I said, they are not tight. You can see how loose that one is. Oh, now let's check this one over here. You see that one is loose as well. It's almost like they forgot to tighten down the screws that attach these balance leads to the bus bars. Terminals, all the screws in the terminals feel tight. They feel fine. We can see that the positive and negative leads here are both a pair of 7 gauge wire, and they are the standard silicone insulated wire with a 200 degrees Celsius insulation rating. The balance leads are neatly bundled together here with some spiral wrap down to the battery. Then the balance leads are soldered to some ring terminals with some heat shrink here. Alright, so as I'm taking this battery apart, there were 2 screws, one there and one there, which you see I've removed here. However, I've just noticed that there's actually a screw missing. So if you look on the other side here, we have a total of 4. Okay, so I removed the top bracket here, and you can see it's very similar, again, to the SOK. It's got 4 holes where the vents line up, and then it's got some very nice pieces of padding down here. I don't know, feels like dense neoprene foam. Not 100% certain on that, but that's what it seems like to me. They actually have these cells clamped together, so this entire module, it looks like, lifts out as one clamped in piece. They actually have this battery pack clamped together the whole way around. I really like it. That's a nice design. And I noticed it's not on there super tight. It actually looks like I can just lift that clamp piece off. Let's see here. Yep. So the inside of the clamp piece, there is that same dense foam, looks like neoprene along all sides in there. So I guess if the cells were to expand, you probably would not be able to lift that off and you'd have to use the screws. But what that's going to do is keep these cells from expanding so much that it's putting tension or pressure on these posts. And I guess really that's the same way the SOK battery is built. It's just that you can't lift the module out as one block of batteries. So they are using serrated flange bolts on this battery. They are using a longer bolt where the two ring terminals were versus a smaller bolt which just goes through a single bus bar. These are GFB cells. They are 3.2 volt, 100 amp hours. And the barcode is 0ALCBA09100000D. More and more companies are starting to use these GFB cells now, and that's pretty good to see because these are some high quality cells. So I did notice there are quite a few markings here on the positive pole. I'm not sure what's up with that. I also noticed there's a line drawn where the clamp was, which is fine. However, on the other side there's quite a bit of stickiness, like a piece of adhesive was applied and then removed. I'm not sure if they put some foam on, then changed their mind and wanted to work with a different design or what's up with that, but as far as I can tell, these do appear to be new cells. I don't know, maybe this is, they didn't say this was a prototype. I didn't see any indication this was a prototype, but I did notice there's a liquidy sound in here. That in combination with the fact that it tested well above 100 amp hours signifies to me that these have not been cycled much at all. Maybe I had actually done the first cycle on them, I'm not sure, but in my personal opinion, they do appear to be new and grade A quality cells. Taking a look at the bus bar here, it does appear to be a piece of solid copper with probably some nickel plating. You can see where they drilled and tapped threads for the balance lead. This does visually appear to be a JBD BMS, but I don't actually see any indication of that anywhere, and it looks a bit odd, like it's either, I don't know, an off-brand of it, or maybe it's just a different model I'm not personally familiar with. The label here does have the DFun brand. It also has a different brand name in parentheses here. The connectors are a bit different too. We've got the standard balance pin. We have this longer connector which is labeled warm up, and then we have this 4-pin connector over here labeled Bluetooth. But these are not the same size connector as a JBD. They're actually a bit smaller, so I can't even fit the Bluetooth module in there to see if that works. So there are no markings on the bottom of this BMS at all. However, we do have a part number here which says DR21S04 100-101-V1. So we've got a second temperature sensor fixated right between the FET transistors, which is great. And the part number on these transistors is SH1004A. But other than that, I don't know. Do you guys think this is a JBD BMS? It certainly looks like one, but it just feels different, so I don't know. Alright guys, so as I'm putting this battery back together here, I did notice a couple of things. First of all, on their website they have a picture of the battery open, and they show the temperature sensor affixed to the screw down in here, rather than to the bus bar. And that's the way I was going to put it back together, but this lead just isn't long enough, so there's really no way to get that screw in, because when you go to close this like a clamshell here, there's no room to get your screwdriver in here by the time this lead reaches down there. Additionally, while I was tightening this balance lead, the balance lead which goes up here in the midpoint of the battery does feel like it's starting to strip out. So I'm guessing maybe that's why they did not tighten these leads down as much as they should have, because they were concerned about it stripping. But if that is what's going on here, then I think they should be using thicker screws, or maybe they didn't use the correct size tap. I don't know, because when I assembled my battery bank, I had no problem at all drilling and tapping copper bus bars, and I was able to get those screws down super tight without any feeling of stripping. So either they're using too small of a screw, or they used the wrong size tap. Again, these are just my personal guesses as to why those were not tight. But yeah, we're going to go ahead and do the low temperature charging test before I close up this battery completely. Alright, this seems to be everybody's favorite test for some reason. So I've got the iCharger X6. It's charging at about 5 amps. There it goes. So I've got some frozen water here with some orange rock salt. And I'll just dunk this temperature sensor in the water and make sure the charging shuts down as advertised. And it does not appear to be shutting down, and I'm fairly certain this water is cold enough. I do see where the wire's going into the BMS here. It does look like it was pulled quite a bit. There's some silicone on it, but I do see some bare wire exposed, so maybe that temperature sensor is not even connected anymore. But I would think if that's the case, I would think it would have shut down completely. Let me go grab some more salt and see here. Yeah, that should be more than cold enough at this point. Alright guys, so I did find a Bluetooth module that had a smaller connector here. And after shaving off some of the plastic around the edges, I was able to get it into the opposing connector on the BMS. The wiring did appear to be backwards, so I did resplice the wires so the RX and the TX were swapped. And I'm able to find the device on the phone, but it is not getting any data back. I did also try swapping the RX and TX again on the off chance that they were labeled incorrectly, and the result is the same, unfortunately. So we can see on the phone here the app does come up and it finds the device, but it just cannot pull back any data. So that's very unfortunate. I would love to see what the parameters are that are programmed into this BMS and hopefully give some kind of indication as to why the low temperature charging protection does not work. Additionally, I did find my thermometer that I had purchased for this, and you can see my glass of ice salt water is currently at -3 degrees Celsius. So my only guess is perhaps that BMS is programmed a little lower, like -5 degrees Celsius. I would find that hard to believe because this was, this has been sitting out for about 15 minutes now, so this would have been colder when I actually did the test. We might try it again one more time just to make sure the mistake was not ours. And one more thing to note is that I did inspect the wiring here, and while there is some exposed wiring, I don't see anything that appears broken, so I do believe we are making good contact, and I do not believe that this stress point here is the cause of the temperature protection not working. So I'm going to turn the charger on one more time. I'm going to go grab some more salt and we'll try this one more time. We're charging at 5 amps. Oh, there we go. It actually worked that time. And our sensor is showing, oh, it's still dropping here because I had just stuck it in. Maybe there is a bad connection at this joint and I just can't see it. Alright, so I think the conclusion from this is that we will call the temperature protection itself a pass, but suspicious quality control on the BMS itself. And you can see we are at -2.3 degrees Celsius, and it does appear to be dropping a little bit still, 2.5. Alright guys, so there we go. I have very mixed opinions and thoughts on this battery. On one hand, they did use GFB cells, 100 amp hour cells. They are top of the market cells in my opinion, and they did test in at a whopping 106 amp hours. However, there were some minor quality control issues. They were missing a screw on the mounting bracket. The balance leads, 3 of the 5 balance leads were not tightened down correctly, and it looked like there had been a little bit of tension put on the temperature sensor at one point. I don't believe that was me opening the case. I don't know if that was done during installation or when that would have been done. Again, on the positives, I do like the clamping bracket they have those cells installed in. Like usual, it comes down to price. This battery sells for $550 with free shipping. The SOK sells for $540 with free shipping on the SOK's website. So I guess while this is using the GFB cells and it appears to be built pretty well, the SOK is $10 cheaper, so why not just go buy an SOK? At least that's my thoughts and my personal opinions. If you guys disagree or have any questions, feel free to leave them below. Or if you have one of these batteries and want to share your experience, please feel free to post that as well. Otherwise, thanks for watching, and don't forget to hit that like button before you go.